Hello guys, Cristiano here. I am a C programmer, learning all those things that I can. Hit the subscribe button, let a comment, that'll help so much the channel. All my videos, you'll be in a fast mode with explanation. I'll reduce the time to be more precise. And you'll face a lot of mistakes and debugs. Everything's calculated, or not. So don't be afraid. The link for all the source codes will be in the description. If you wanna follow, just get your copy. This is the last video about OOP in C. In this video, we are going to talk about the most important pillar in OOP, the abstraction. The abstraction allows us to extract all the common points in a certain group, making these common points as a basis for all of them. It's not inheritance or polymorphism. I see some similarity here. Yes, and it is. With abstraction, we can hide all the internal implementation details from the user. Is it encapsulation? Yeah, it is. The abstraction pulls all other pillars together. In simple terms, abstraction is the combination of the three all pillars. If you think about it, a set in math is like a universal set. Abstraction contains encapsulation, inheritance, and the polymorphism. The abstraction is the most hard to grasp. It is the place where everybody fails. The fact is, the abstraction has a very close relationship with modeling. And modeling, my friends, is not easy to master. It takes a lot of time to understand the problem and they represent this problem as a model. To keep the model precisely next to the reality, he needs constant evaluations, like new spots reveal the truth of a new item or a new understanding about the business. You need to rethink the object's organization to see if it still makes sense. To exemplify the abstraction, you are going to abstract the car movement, where you need to turn on the engine, and drive for an amount of time and turn off the engine. Just to remind you, I'll use the oriented error approach. You know, this approach avoids to have problems with memory management. First, we start with a folder creation. To make things here quick, I'll provide the build script that I copy from polymorphism example. To centralize the behavior, we are going to create an interface with a car base. This interface has reference to object that implemented it. To control the car, we need an object known as manager. The class will handle this car. First, we create a control context where inside it, we'll have an interface which receives a car as a dependency injection. The manager will have two functions, one to initialize the control context and the other to drive. To simulate the drive time, we put a sleep, nothing special here. The init implementation is quite simple. We start the control with an interface received by argument. In the driver function, we use the template pattern, or is a good try, which defines the behavior in a chained functions. First, we start the engine and check if the engine is really on. We do drive for a while. After the time driving is over, we can shut down the system, turning off the car engine. To control works, it is necessary to have a car to control, obviously. For that, we need to create an car abstraction, which will have the speed and the name. And this car needs to implement the interface to be controlled by control management. It is a good point for a reminder. The interface must be the first attribute in the struct. In this example, I use just the open to initialize with a name and a speed. To make things easier to implement the interfaces, we copy the functions in interface and paste in the car file, and we can do some tweaks adding the prefix make when as private. We are going to implement it soon. We copy the interface to load the car reference inside the interface, and then next the name and the speed. Filling the interface with their implementations, we return true here. In the car on, we cast the object to recover the car, and we print the car's name if it is on. In car drive, we show the car name and its speed. In car off, we show the car's name and it was turned off. We add the engine string to make more sense. Now, to test the implementation, we create two instances, one for the car and the other for the control. We configure the car as Toyota with speed in 100. I did not put a unit here, can be miles per hour or kilometers per hour, your call. We start the control using the car already configured, and we drive for 5 seconds. It is a good time to test, I think. Compiling, executing, now we can see the messages, which the car was on, we drove for 5 seconds, and we turn it off. We generalize the car implementation. Nothing stops us for creating new car types, as we saw in the early videos. how we can do it. This example was simple try to abstract the behavior of how we can drive a car. Totally simple, but I believe it was enough to have a quick taste of how the process works. The abstraction demands a lot of knowledge about the problem, which is desired to modeling. It is kinda hard to find out systems where the company cares about the modeling. To help in this modeling process, it is normal to use the UML. This kind of research gives a big picture how the solution will be and how the objects will talk to each other. Finally reached the end of the series, we saw the 4 pillars of the PNC. For all codes that I write nowadays, I use that style. I really care about code beauty. I hope you guys like it. Now it's practice. Let's get ourselves hands dirty. That's all for now. I appreciate it if you get here. Don't you forget to hit the subscribe button, leave a comment and share. Knowledge is not enough. Waiting for more. Bye. See you soon.